All right, welcome to PROG 2006. There is a question how we deal with the point system and difficulty of the labs. So in general, we have two things. We have three things. So let's do this. So one thing is an exam at the end, and this is anonymous, and this is an exam which everyone takes online, and there is a grade for the exam, right? So there is a exam grade, and the exam is a mixture of theory questions, some thinking questions, and some small coding questions. So I will talk about the exam later, like towards the end of the course, and then we will clarify the exam, but it's relatively self-contained and simple. Then we have obligatory work. Obligatory work. And the obligatory work is basically what needs to be done to pass the course. If you don't do the obligatory work, you will pass, you will fail the portfolio, and you will also not be allowed to take the exam. So obligatory work is the minimum amount of work that has to happen for you to be able to submit the portfolio and for you to be able to take the exam. And the obligatory work, for the obligatory work, the points are important. Important because there will be a certain limit. I am currently thinking about 35 points that you have to accumulate from various labs to be able to be ticked off for the obligatory work. So obligatory work basically boils down to you accumulating certain amount of points, and that is most likely the number that I will propose. This number depends on the point system of the labs and difficulty of the labs. So I'm kind of still working out what labs we will have this year, how many, and how many points in total people can accumulate, and what is the kind of the minimum requirement for passing the portfolio. If you accumulate that amount of points, you are finished with obligatory work. You are done with the minimum requirements to pass the portfolio, so you at least will get E. Normally, you will get D for 35 points. If you only have 35 points, you will get D, and you don't have to do anything else. And then you are allowed to take the exam. So this is the kind of obligatory work part, and it relates to the lowest grade of the portfolio. And then we have the portfolio. So portfolio is the graded component. So as I said, like if you accumulate 35 points and you submit the labs that you've done to accumulate those 35 points, you are like you have already accumulated enough portfolio to pass the portfolio, and you will most likely get D. And then if you want a better grade, you have to do more for the portfolio, but then the point system is not relevant anymore, right? So then you get grade for the portfolio, and the grade for the portfolio is based on the work done and the difficulty of the work done. So the more you've done and the harder it is, the better grade you will get. It is a little bit not precise mathematical formula of how to get, precise point system, but it's kind of a good indicator that if, let's say, I don't know how many max yet, but let's assume that the max is 90 points or maybe 80. Then you can kind of estimate that on roughly speaking, the points reflect the difficulty of the work. And then roughly speaking, between 90 to 100% is A, between 80 to 90% is B, and so on, right? So the typical formula that we have, 60 to 80% is C, and so on, right? So that's what we take into account. The amount of work is not as relevant as the difficulty. So to get those kind of a higher scores, you have to do the harder labs and get the harder sort of work done, right? So this is how the structure of the evaluation works, and this is what is the relationship between the obligatory work and the portfolio. You can submit in the portfolio the work that you have not counted towards the points. That's fine. And you can also submit in the portfolio work that you have counted towards the points, but you've redone it like better or whatever. You are evaluated for the portfolio here, not here. Here you are only evaluated so I can send the exam office a list of students who fulfill the minimum requirements. They are allowed to take the exam and they basically effectively pass the portfolio, but the grade is done after evaluating the portfolio. And the portfolio is all the labs and everything else. I will talk a little bit about it in a moment. What else can you do? But it's sort of the submitted report with all the repos and the description of what you've learned and what you've done. So this is the portfolio. So portfolio is effectively a report, all the work in form of repos, and a short video describing what you've done, like what you are the most proud. You don't have to go through every single lab because that's what you've done with TAs anyway, but we have to have some report some report and the video such that an external evaluator can kind of review your portfolio and say, yeah, that portfolio is worth B or that portfolio is worth C. Okay, so for making their job easier, we have a report. We have all the repos, so the work, right? And then we have a report and a short video. And the short video is to highlight the most hard parts or hard things that you've done that you're most proud of. And that's it. So currently, we're kind of doing the labs and accumulating the points to get to the point where we are sort of done with the obligatory work. Okay, so how the points affect the grade? They don't really affect the grade, but they are an indicator of how hard stuff is, such that if you want to get a better grade, you should cherry pick the harder things. Because if you only do the easy things, you will probably not get the grades that are kind of for the harder work. So it's not directly related to points, but it kind of indicates kind of where you are. Just to clarify, you don't expect us to do the advanced solidity lab? Yeah, I will talk about it in a moment. Do we have to do the portfolio of points if you did the course last year but didn't take the exam due to the illness? Yeah, so there was a student who checked that, and the exam office works like this, that to change a grade or to get a grade that you didn't got last time, you have to sign up for the course. You have to sort of be signed up for both exam and portfolio, but then you can opt out from one of those elements. So like if you didn't take exam, you don't have to repeat the portfolio. You can take the portfolio grade from last year and only redo the exam, and vice versa. If you've done the exam and you passed, but you're not happy with the portfolio grade, you can take the course, redo the portfolio, submit the portfolio again, but opt out from the exam. And then you will have a new portfolio grade and the old exam grade. So it seems exam office is quite flexible, and they allow you to retake the element that you want and take the element from last year, the one which you don't. Okay. More questions? So the solidity lab I will talk in a moment. And what else did I say? So let me write here that I don't forget. Lab. Okay. What else? What there are other questions or something that I said I will talk after, but I didn't yet? What programming languages will be covered in the exam? In the exam, it will be Rust and Haskell. There are some exam questions which allow you to do something in a language of your choice. So you can pick your own language arbitrarily. But 80% of the exam is Rust and Haskell. And about 20 to 15% is like, okay, do whatever you want in whatever language you want. Exam is with no aids, and particularly there is no chat GPT or Copilot allowed. So exam is kind of closed books. You have to only use your head and some material which is given in the exam. So it's kind of good idea to practice some things. Of course, I encourage you to use ChatGPT and Copilot, but I discourage you to let it code for you because then you will not like develop certain skills that will be useful in the exam. So you kind of need to be able to code things yourself. All right. So if you have questions, extra questions, please ask. And then I will cover them. I will cover Solidity Lab in a moment. And let's let's move on. Let's kind of start with the Menti. So uh, let's yeah, you can like the best is probably to post questions in the chat because those I see immediately. The ones here I will only see after I review them in the Mentimeter. All right, so deadlines. So there was a question about soft and hard deadlines. So I answered that already. So soft deadlines are for this extra point and to make you incentivized to do things regularly. Don't postpone everything into the last minute. And then the hard deadline is for closing a particular lab such that we can discuss it in the class. And after discussing it in the class, it is kind of not possible to submit it anymore. Why we do that? Like most of the labs, they have some sort of thinking to do, and then when we discuss it in the class, then this thinking is gone. So you sort of don't have the benefit of solving a puzzle. So it's like I give you a puzzle, and then you're trying to solve it, and then in the class we discuss how it is solved, and then like after that, it's like it's not a puzzle anymore because you already know the solution, right? So then it's like limited utility of for learning or for acquiring skills. So after the hard deadline, it allows me to discuss things in the class, but then we don't take those labs anymore. We meet for you to ask me questions. That's the primary purpose. That's the primary purpose for us to have those sessions. If the lecture is me talking, I've already done it. So there are videos and there is a question, where are the posted videos? So if you go to the course, yeah, so if you go to the if you go to the Discord page and you go to Wiki, you will see that there is a tab called Lectures. And if you go to Lectures, you will have a page with all the lectures. And then I try to link up all the videos and slides on this page. So all the recorded videos are linked up here for your convenience, but they are usually posted on Panopto or YouTube. So you can also dig them out from those two resources. And in home, there is uh, yeah, there is no link to the. I will put the link into the on the homepage to the YouTube channel. Oh yeah, it was there. Sorry. So there is a playlist for PROG 2006, and I try to make it organized such that all the PROG 2006 recordings go to that channel, so you can keep track. I I might have not linked the last two videos to this one. Probably my mistake. I will check it after the lecture. But you basically have the lectures here. So this one is from yesterday, and it was given about solidity to the max students. You can review this, but it's in Panopto. All those ones are for today, and those are on YouTube. Those two are quite longish and go a little bit more into details. And this one is a little bit shorter from last year, very similar to what we covered today. But because what I want to cover today is already in this video from last year, I'm spending more time answering questions, and I will spend a little bit more time on some auxiliary things today. And then the more content is here. There are obviously I review those videos occasionally, and I reviewed this one yesterday and this one, and I found some mistakes. So if you're watching a video with a lecture, or even if I'm giving a lecture, and if you spot a mistake, then you should issue an issue tracker issue and point out to that mistake. And then if you do that, you're gonna get extra bonus points. We have this kudos extra credits page where you got extra recognition for doing some things, and finding errors. It's quite profitable, so you should try to spot errors. So I will spoil one error which I spotted in this video. So in this video, I'm giving examples of destructuring. What is this destructuring? And I'm giving an example of, let me go to, let's see, Golang playground. So in many languages, you have tuples, and you can destructure tuples. So for example, if I'm doing Golang, then I have a function foo, which in the lecture I'm taking an int, and I'm returning like two ints. Okay, it's just conceptual thing. It's very contrived example. So I'm doing something like this, and I return AA, right? So I'm kind of returning two things, and then in my main, I'm saying, okay, get me what A is from foo and pass 10 to foo, right? So can you do that in Golang and treat this A as a tuple of two things? And the answer is you cannot. In the lecture, I sort of use it as an example that as if you could, but you actually, it does not work. It works in some languages. Rust has tuples, so in Rust you can return a tuple like this, and then get the tuple as A here. But in Golang, you actually cannot, but you still can return two things from the function, right? So then I can do this. But I cannot get A and then say B, C, and destructure A, right? In some languages you can. So if A is a tuple, I can destructure it into two things which the tuple has, and treat it as a tuple. But in Golang, you actually don't have tuples. And the only way you can get those two values back is by doing this and destructuring the result into those two variables right in here, right? So there was like this small mistake, syntactic mistake, which I spotted. I should get a bonus point now. But because I already passed the course, I don't need the extra bonus. So if you spot any other mistakes, then issue the issue tracker, and you're gonna get some bonus points or some kudos, you know? If you spot a mistake that you think is a mistake, but it isn't, but then we have a discussion, you will also get bonus points because you will spark a discussion, unless it's completely meaningless, right? So don't abuse it. But even if you're not quite right, it's kind of good to discuss, okay? All right, more questions? Okay, so there is a question about how to review the code with TAs and how to do it like with the code. So Normally you have your workspace, and in the workspace you accumulate the work that you're doing. So you organize it the way you feel is the best for you, usually by labs or by some sub projects or how you want. Like it's entirely up to you. And then you keep your work there. You keep the work there, and then you don't need to make it internal, and you don't need to make it public. And when you're creating your projects, create them privately. So only you can see them. So other students cannot see other people work. And then once you're done, you're meeting with a TA and you're saying, yeah, I've done the lab one. Here it is. Like, this is how it works. And then the TA may ask you one or two questions, may ask you, okay, where do you do this? Or can you change this to this? And then you demonstrate that you've done the work, that you know how the code works, and then you get ticked off. So it's a very short show and tell where you, in front of the TA or me, you are demonstrating how it works and what you've done, and then you are asked one or two like control questions about the work. So the question can be, oh yeah, can you change it to I don't know, like in the context of rock, paper, scissors can be, okay, where do you encode, where do you compare the submitted solution to the committed hash, like how you do that? Or why is that function pure, okay? And you have to have a reason. So there will be some sort of a kind of question for explanation, right? So what if you cannot be present in the lab to show the TA? You can request the code review remotely. As I said before, you talk with the TAs on the Discord and you arrange meeting like in Discord to do a screen sharing and kind of a showing them what you've done. So basically the labs you're doing at home yourself, you can use tools, you can use friends, you can do whatever you want. And then the kind of getting a tick for the lab is presenting like show and tell. So presenting what the lab is doing, either through screen sharing in Discord or physically, and answering like one or two questions. If you cannot answer the question, then it's not that you failed the lab. It's like, yeah, you go back and you study a little bit more. And then you come back and you try again, right? So sometimes you get a question and you don't know why something is like that. Maybe you use like a copilot and the copilot generated something and that he asks you like, why are you doing this instead of this? And you're like, I don't know actually. Then you go and study a little bit more and come back and say, yeah, now I know I'm doing now this because of those reasons and so on. So it's kind of very flexible. You can try submitting a lab more than one time. Obviously, don't abuse it, right? So don't back the TA multiple times and you're not prepared. Like, prepare yourself, like to read your code, like what is it doing, right? Yeah, so the deadlines last year, the deadlines were at the end of the lab, and that is up to us. Like what? So the question is, should the deadline, the soft deadline, be midnight on Friday, or should it be the end of the physical lab? For the health of the TA and for your planning, I think if the deadline is midnight, it's a little bit meaningless because on Friday evening, I'm not working and I don't expect TAs to work. So if you are ready, like, 11 o'clock on Friday evening and you say, yeah, I'm ready with the lab, let's get an extra point being on time, there will be nobody to check it. And then you're not going to get extra point on being on time because there is nobody to check it. So from practical reasons, I think the deadline should be the end of the Friday lab when you actually can check in the lab and people are waiting for you to check in the lab. So I'm proposing the soft deadline to be the end of the lab on Friday. And the hard deadline is the same, is the end of the lab on that Friday. What do you think? If you request the task to be reviewed within the deadline, but there is no one who is able to check that in, will you still get the extra points? No. So you have to be checked by the deadline, not to do the task by the deadline. It again, for practical reasons, a lot of people might be ready in the 2 minutes to the deadline, and then how are we gonna handle that? That there is like a limited amount of TA ability to check everybody. So it would be sort of difficult for everybody to be checked in by the deadline. So we have to have some sort of mechanism for spreading it. So if you want to work for the last minute, you're taking a higher risk of not being able to be checked in. And if you want that risk to be low, you do it earlier, and then you have more opportunity for the TA or me to check you. So it's kind of a like flexible system that will self-regulate. Yeah, so there is a more complicated mechanism for trying to use the commit time and then do the submission based on the time. We could do that, but I personally don't really like it. And maybe the TAs will not like it because it will promote people to be ready really after the deadline, because everybody will commit 1 minute to the deadline. And then the TAs will have a pile of work to be checked after, right? And it will be not spread. So the whole point of the soft deadline and making people to work regularly is to spread the load kind of as possible, such that the DA suddenly don't get many students to be checked. So I'm open to this suggestion. So we could use the date. So let's maybe have an issue in the issue tracker, and let's vote like who wants the date to be the marker, or let's make the deadline to be the actual deadline, and then it's sort of self-regulating. Yeah, I'm open for the suggestion, like whatever the majority would like to have. I don't want to impose one or the other, but at the same time, I want to give priority to the TA to express what they think and what will make their work the easiest, right? So yeah, let's make an issue out of it, and let's keep this week for the discussion. So whoever is ready with the lab 01, let's keep it such that we use the deadline rule because it's like more encompassing. But from the next lab, we will sort of make the decision. Okay. All right. Okay, so let's come back to the Menti. Yes, asking questions and watching videos. So I do encourage everybody to watch the videos. And then I sort of explained the labs and labs difficulty already, such that it is the labs points are needed for the obligatory work. And then the labs points are also suggesting the difficulty. It didn't really work that great last time, because a lot of labs that I thought were quite hard turned out to be quite easy for students, or vice versa. And then the point system was not exactly equivalent to the difficulty. So it's not, precisely mathematical relationship, and everybody solves some things with more or less ease. So it depends on the students. So it is just the indicator, like for the difficulty, right? Um, and I expect your feedback. So if certain lab is really hard, then you should tell. And if certain labs are kind of okay or easy, then you should tell as well. And then this relationship will get more adequate, more yeah, more in line. Okay. All right. So I hope we sort of covered those 3 points mostly, right? If you have more questions, just ask or make an issue in the issue tracker. So let's move on. Why we are studying solidity? There are many reasons for that. Okay, so this first. Solidity has a certain concepts which are quite interesting um, from the software engineering perspective, and it is difficult to discuss them with other languages or with other concepts because they don't exist outside of blockchain or smart contracts. So it is quite a new and emerging technology stack, and it's very popular among certain circles. And one of those circles are programmers. So a lot of programmers are super hyped about smart contracts because it democratizes not only ability to work on code, like what open source like GitHub or GitLab democratized. Um, in the old days, to work on code, you have to be hired by a commercial company, and there was no real big open source projects. And you couldn't just say, oh, let's do kind of image processing software. And you were not able to do that from your home because you were too small, and it was really difficult to organize into a team, and the teams were organized by commercial companies. So the open source movement and open source initiatives and tools like Git really democratize it. So now you can work on an open source video processing or image processing software of very high quality from your home together with top people from around the world, and it's like free, like you can just do it. And then Solidity and smart contracts not only help with that, but they help to incentivize in a form of value, in an economical value, into the projects which are kind of building something new. So you can have now a community which not only works in spare time on something that is open source, but also on something that sells or provides services that are being paid by users inside the ecosystem, and you can get value out of that immediately. So you don't have to be hired. You can sort of do that again from your home, and no, you don't need to ask anybody permission, and you don't need to um, being hired by anybody neither. So it has a lot of potential and a lot of incentives, and it's very popular among programmers who suddenly find themselves being able to sell their skills themselves without kind of commercial companies. And there are some other reasons. So digital wallets, the EU is working on digital wallets, and some of the credentials and some of the things will become digitalized, passports and things like that. And then, central bank digital currencies are coming. They already came in China and are coming in other jurisdictions. Governments will push it because it gives them more control, and we will have programmable money. So in maybe 10 or 15 years, when your kids understand the world, then you can explain to them how it happened, and how is it that when they go to a shop and they try to buy cigarettes, they cannot pay because the wallet checks how old they are and they are buying cigarettes, and the programmable money prevent new transactions to be issued if they don't fulfill certain requirements. So it will be built into the protocol that your card will not work if you're underage and you're trying to buy, alcohol or cigarettes. And then you will know how it works because you understand exactly how it happened and why it works this way, right? So this is why we have Solidity. And the main point for you is to understand how it works. I don't expect. So there was a question that should we do the Solidity labs? You don't. You can get enough points to get good grade in the course without doing the 2 Solidity labs that we have. But if you're interested in it and if it's something that you find inspiring, you can do. So you can kind of do the Solidity labs. So that kind of, let's go back to this one. What should you do for the portfolio? So there is infinite amount of possible work you can do. You can do all the labs, you can do extra projects, personal projects, you can do like whatever whatever you want and include it into the portfolio. But you have a finite time. So the amount of labs that we will have will be more than you can do in the in the time of the course. So by design, the course will have more labs that I expect you to do. So I don't expect all the labs to be done. Of course, some students might be so keen and so dedicated that they will do all the labs, but that's kind of an exceptional situation. Last year, I don't recall that there was maybe one student who did all the labs, but normally students did like most of the labs, but they skipped one or two for sure. And that's the case. So don't put yourself like under pressure that you have to do all the labs. No, you don't. But if you want to get A, you should do the hard labs. Because if you only do the easy labs, then you're not gonna get A, right? But you don't have to do all the labs. So pick your battles. And then quality and depth are much more important than the volume. So as I said, like don't go for the volume. Like, oh yeah, I have 10 personal projects and they are all crude, like read from database and write to database. Then yeah, that's kind of C, okay? Even so what if I have 20 of those? Yeah, that's probably C as well, right? You kind of don't go out of the comfort zone and of the difficulty level of a crude application, okay? So you have to kind of challenge yourself. You have to do something that is actually challenging. Then you go to B or A, right? It's not that hard. Like it's not that hard to pick battles which are kind of hard. So try to do that. Um, we can talk about the portfolio and the labs later when I publish more labs. So then we know. The current labs are like Solidity, which is very niche. You don't have to do it, like if you don't want to. And then we have very easy lab for Haskell. Everybody should do it, right? Like even if you want A, you should do the easy lab for Haskell. It's gonna take you very little time, and it's like a cheap way of getting points, right? So do it. Um, um, do we have to create a check task issue or can we just approach the TA during the lab? Yes, you can just approach the TA during the lab. But if you have the check-in task, you can tell the TA, look, I'm the first on the list. So if there is a queue, you can kind of cut the queue because your issue is first on the list and you have the priority. So the issue tracker is a little bit like the ticket system where you get priority over others if your issue is in the queue, right? So that's why we do suggest you actually submit the task in the issue tracker and then approach the TA if you can. And then if there is a queue, you find like you know where you are in the queue, and the TAs will also check that, and then they will prioritize people along the queue. So then people who finish the labs earlier have priority over people who finished the labs later and submitted the task later. Okay, so it's just a queue system. All right, so let's move on. All right, so I recorded this lecture already a few times, and those recordings are on YouTube, and most of them are pretty good. Like I will not say a lot of new things. Every year I'm trying to say something extra, but the core material about Haskell and about what we are doing here is there. But this year I decided to do a little bit focus on something that most students kind of miss. You are, you know, it's a fourth semester. You are beyond the half of your studies, and most of you get it, but some of you still don't quite get it. So what I will do is I will rant for maybe 10 minutes, and then I will explain a little bit of what this course is about. We're gonna go without a break today. Let me stop for a moment the recording. Okay, so about skills. Some of you kind of know the story about learning to crawl before you can walk. So let's kind of revisit it. So I have a student coming to me and says, oh yeah, sensei, teacher, I want to learn to run and I want to climb the mountains and I want to do those nice things in life. So please teach me how to run and teach me how to climb the mountains. And I will say, yeah, that's great. That's good goals. Let's start with crawling, okay? And then the student says, oh, really? Crawling? Yeah, I can see kind of crawling kind of is helpful, like when you're fooling around on the beach with friends. And maybe I will do a lot of crawling if I'm like in military, but I really don't want to go to military. So kind of, I don't really see crawling to be that useful, right? Um, I don't really want to do career in crawling. I don't want to go to military. So do I really need to start with crawling? And then I say, yes, yeah, let's do it. Let's start with crawling. And the student will be kind of not super happy, right? They will don't see, they don't kind of don't see why they have to start with crawling if their goal is not to do crawling, but to do climbing and, you know, running, right? Um, so then we go back to the concept of enabling skills or of transferable skills. So enabling skills are the skills that you get and you can apply them in different domains and in different contexts. So some of those transferable skills is the spatial awareness, right? Spatial awareness is like you know where you are and where your limbs are. Super useful when you want to run or when you want to climb. And crawling, super important as well. Good training for spatial awareness. Coordination between four of your limbs and the muscle strength, right? So these enabling skills, which the crawling enables, allow the student later to acquire more complicated skills like walking. Walking is not different form of crawling. They are completely different. It's like there is no need for a child to learn crawling before they walk. In fact, my daughter learned to walk and she never learned how to crawl initially. Then she learned to crawl after she could already walk. But the crawling enables you those transferable skills, right? Other transferable skills like logical reasoning, pattern recognition, creativity, effective communication, effective ability to express what your thoughts are, those are all transferable skills, okay? And then we have meta skills, and those are like even better. Those are higher order abilities that allow you to acquire other abilities even better, right? So the meta skills such as learning how to learn, critical thinking, problem solving, and self-regulation. Those are skills that make you being able to acquire other skills even easier. So you become sort of like a super trainer because you can train yourself in new things better than the one who does not have those meta skills, right? So the meta skills allow us to acquire new skills in a more efficient and better way, right? And those two concepts, the enabling or transferable skills and meta skills, is super important. And my student here is kind of not getting it yet, right? Like if I try to explain, yeah, you know, I want to tell you about those transferable skills, and that's why you kind of need to learn to crawl. They you know, at that point, you probably didn't get it, but you still did. You still learned how to crawl. You acquired kind of a spatial awareness and coordination, and then you could start to walk, right? So those two things are super important, and they are quite surprising. So we often don't think about this when we do our activities, right? So here we have people playing Go. Go is a very old, one of the oldest games in the world, and considered to be the hardest game there is. So many experts agree that playing Go is one of the hardest skills that you can intellectually engage in. Why is that? Well, it's kind of very complex game, which teaches people a lot of transferable and meta skills, and they can be applied in computer science, in problem solving, business strategy, and so on. And Asian countries are super stoked on that. In Western countries, we often use chess as an example of a kind of a valuable game that is worth learning because you can transfer some of the strategies and some of the thinking that using in chess to other domains. But Go is even better. It's like a next level compared to chess. And it is very popular as a teaching subject in schools in Asia. So students learn it not to become Go game players, but they learn it to get those extra abilities, right? So you have some logical and strategic thinking, problem solving, decision making, very good in abstract thinking. So you're thinking in terms of influence, territory, and potential rather than immediate gains from your moves. And then it's super useful for, scientific research or programming or, uh, you know, different domains, right? So it's not about Go, but the concepts from Go can be applied elsewhere. And I have another long slide about this, so you can check it out. There is a lot of benefits, and those are only two slides, but you can spend like a book about how playing Go affects strategic thinking and kind of mental capabilities of the people who engage in this activity, right? So great. Um, you know, I picked up playing drums. And playing drums is a transferable skill because it teaches you independence of your four limbs. So, like by engaging in this training, I become a better paragliding pilot because when I'm paragliding, I have to have both hands and kind of both like hip movement independent. So I have to be able to do with my body complex processes, complex things, which are the same as in drumming. Okay. And then I'm also an avid climber. And then with climbing, it's similar. I have to be able to be quite independent with all my four limbs. So, playing drums helps with the other two things, which are completely unrelated. So all those activities have certain meta skills or transferable skills, which are applicable to other domains, right? And then we go into the next level. So we've already covered the ability to learn some things, and ability to learn something faster, and ability to acquire skills faster. So like, for example, if you have the base level, you're doing Python programming. So we have a lot of people who say, I am a Python programmer, right? Do you need to go to university to be a Python programmer? No, you don't. You can acquire those skills via normal vocational training, and you can go for a course and you will become good at that skill. Okay, so that's the normal kind of a base level. So it's the same with driving a car, right? You don't need to go to university, or you don't need anything kind of really spectacular to learn a skill. And that skill is like driving a car is in itself kind of transferable because you have to have special awareness and all those things. So driving a car is not only about driving a car, but it's kind of on the base level, right? And then you have this sort of a higher level. So then you say, no, I'm not a Python programmer. I am programmer. I can program in any language. I can even program in languages that I don't know yet. I know I can do it, right? So you sort of, because you are able to transfer the skills that you have into something that you can quickly acquire. So if you go to a job and the job says, yeah, we're gonna program in a new language. It's called, I don't know, Mercury, okay? And so, yeah, okay, yeah, show me what that language is like. Is it like Rust? Is it like Haskell? Is it like, JavaScript? Oh yeah, it is like Erlang. Okay, fine, I will sort of learn what I lack, and I will be able to be productive in a short time, right? And the same is like playing Go. And then there is a mastery. And mastery is like you go from being quite good in the meta and transferable level, and you go really niche, right? So here we have quite a niche because you're specializing. You're saying, I'm a Python programmer. Here we go kind of meta. We go wider. We say, yeah, I'm a programmer. Any language. I can do any language. I'm a driver. Like here you say, yeah, I can drive an automatic car. If I need to drive manual, yeah, I'm not so good. And here you say, yeah, I'm a driver. I can drive any car, like automatic, manual, a semi-truck, no problem. I can drive it, right? So we go from specialization to meta. And then for mastery, you go back to specialization and you go to niche, right? To be here, you need, yeah, years, right? It's not, you're not gonna get there during the university. You can get there like in 5 to 10 years of going into niche. And what is a niche, right? What does it mean? It means you're gonna do weird things, right? What is this guy doing? This guy is doing exercise for his neck. Like what the hell, right? What is that? Well, he is a Formula One driver, and he needs to train his neck to be able to withstand the G forces. And being a Formula One driver is not like it's not like he's a driver. No, 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 no. He's a driver to the next level. It's like the normal, you don't do that. You don't do that when you're getting your driving license, right? So the driver and the Formula One driver, those are completely two different drivers, right? So it's the same here. If you say, I am a blockchain expert, I'm a solidity expert, that means you gave up on everything else and you concentrated on digging in deeper and deeper and deeper into more obscure things of Solidity or C++, okay? And then there is a gap, there is a huge chasm between you and everybody else on this level or here, right? So the same as with the driver, right? So the Formula One driver is not just a better driver, is a completely different category of drivers. So we kind of in the university, we do this. We are trying to be here. And this is not important. Like acquiring individual skills, like being like knowing how to do Python or knowing how to do Haskell, that's here. And that's what you expected to do on your own already, because we train you how to learn. And learning those individual skills, it's on you, not on us. We are here. We are trying to teach you how to acquire those transferable and meta skills instead, right? So we're not going there. We're not going into niches, and we're not expecting you to go so deep into anything that you become a master in a 3-year program. That's impossible. But it's possible for you to acquire very long-term meta skills and transferable skills. So that's that. So then, why do we study Haskell? Well, good question. So is this course about teaching us English? Do we study English here? No, of course not. This is a programming course, right? But we use English. So do we actually learn more English by using English? Yeah, to some extent, true, because we are forced by me, the teacher, or the setup, that the language of communication is English. Of course, we improve our English skills, but the English is just a tool. The English is not the purpose of the course, right? So the same as with Haskell or Rust. Is this course teaching us Haskell and Rust? I say no. You say yes, but I say no. Haskell and Rust is like English. Haskell and Rust is just a tool for me to explain to you something. It's the same as English. English is just a tool for us to communicate, for me to explain to you something. So I am not teaching you Haskell and I'm not teaching you Rust. I'm teaching you something else. But for us to speak English, we both have to understand and be able to communicate in English. And for us to use Haskell and Rust as a tool, we both have to be able to do that. So of course, there is some learning about Haskell and Rust such that we achieve certain communication, because if you have no idea about English, then the communication cannot happen. And the same with Haskell and Rust. Why we use Haskell and Rust? Because there is a huge overlap between Haskell and Rust, which Haskell is like a superset, but there is a little bit niche, more specialized concepts about memory management and about strictly typed languages which enforce manual memory management, which Haskell does not have. Everything else is the same, but that memory management part is unique to Rust. And that's why we have Rust in the course. But most of the course is about Haskell because on concept level, they are the same. The same concepts are here and here. Only the part about manual memory management is here. And then Haskell has some unique things that Rust don't have about meta classes and using, for example, monads. And those concepts are here, but they're much harder to explain. That's why we use Haskell. So why we have Solidity? Yeah, I explained before, because Solidity has certain concepts like programmable money, like moving money around and deciding what happens with the money by ensuring that preconditions are met. There are not many languages which allow you to have annotations on the functions which enforce certain pre and post conditions. And Solidity is a nice example about that. So there are certain things that Solidity has which are unique, which we can talk about. And then we kind of using Haskell and Rust for learning about what? So what is the course about? Okay, so that is also a little bit of abstract, but let's imagine that I give you this example, right? It's a simple arithmetical equation, and we are now saying, yeah, it's a kind of a problem. And then the learning is not about knowing that the solution is 200. The learning is about knowing how to decompose this problem into smaller problems and then how to solve it. So it's not about the answer, it's about the process, right? It's about the thinking which goes behind the problem. So we have a problem, and then, of course, we have a solution, but the training and the learning is about the process. And the process is about being able to do addition, being able to do division, being able to do subtraction, and being able to combine those different vocabulary elements, those different concepts together, and then being able to do it, right? So if you have an example, and then the example shows you how to solve it, you're missing the point, because the point is not the answer. The point is this. The point is the process, right? So to make it less abstract, let's do a kind of a simple kata. So in the previous years, I did that kata later, but I think because it was buried at the end of the lecture, some students kind of missed the point. So the point in the context of what we just discussed is that we have a simple problem. So the problem is that we have a list of numbers, and we have to produce a string, which is a comma separated list of those numbers, right? So this is the problem. So how you gonna solve it? How you solve this problem? And then I can show you the kind of idiomatic solution, and you will say, oh, aha, that's how it is solved. But that's not how it is solved. It is solved by us thinking about the problem and us having the vocabulary to think about the problem, right? So when we have this problem, it's a very simple kata. So kata are kind of a simple puzzles, which are quite simple, and then they have kind of an insightful solution. But to get this insightful solution, you have to kind of think what is needed, right? So for this problem, because I've already studied that problem, I know that there are certain, like it's the same as this, right? It's the same as this problem. You kind of recognize, oh yeah, I mean, I need to know how to do the plus. I need to know how to do the division and minus. And once I know how to do those, I know how to solve it. And then the details of how you're doing the addition, like, can you add this like in your head straight away? Maybe you can, maybe you have to say, no, I cannot. I have to add 1 to 4. Okay, that's 5. Then 8 to 3. Okay, that's 11 with 1, which I carried. So that's 2. And then, you know, you do the addition like in a kind of a linear way, and so on. So there are different ways for implementing what needs to be done, but you sort of have the solution like right in your face here, right? And it's kind of interesting because in the previous slide, it is right in the face of a person who understands the arithmetic. And here it's right in the face of a person who understands this problem, but it may not be right in the face for you right now because you haven't studied that problem yet. And you haven't studied how to solve it in a functional way, right? So maybe you're thinking in a very iterative kind of way, which involves using a for loop. And then you say, yeah, I have to take this first element, I have to turn it into a string, then I have to concatenate it with this, and so on. So you're kind of trying to solve it using the vocabulary that you already have from the previous courses and previous experiences of programming. But for a person who has quite a rich vocabulary, it's quite obvious that you can kind of turn it around and you can say, yeah, so I will show you here. So let's go. So if I go to the Haskell interpreter, okay, let's do it on top of the screen. So I'm in Haskell, and then I need a function which, given a list, so I kind of need a function which, given a list, will give me, which will return me a string, right? So it will kind of return me a string. So that's what I need. So I need f, which, given a list of elements, gives me that string with those things, right? Okay, so the function will kind of be of type that it takes a list of what? Of numbers, but do I really need to constrain it to numbers? Will my solution work for anything? Yes, it will. It can be generic. So I can say it's generic for anything, and then it returns a string, right? So this is kind of a signature of my function, that it takes anything and turns it into a string, which is this kind of a comma separated list. And then I see in my head that I have to turn whatever that is into strings. So I have to convert everything inside the list to a string first, because it is not necessarily a string. So in this case, it's a number, int, it could be a float, could be a complex number, could be a struct, could be something, right? So I have to turn everything into a string. So I have to map a show function. So show turns whatever I pass to it into a string, right? And once I have it, once I turned my list into something which is a list of strings, I have to combine all the elements, interjecting this sequence, right? So sorry. Yeah, my mouse does not work. This sequence. So comma space, right? I have to interject comma space between the elements. And there is a function. So if you go to, you probably don't know from memory because you have not experienced that before and it's not in your vocabulary, but there is a function called intercalate, and it basically is a function which does what we need. It's a function, it's a function which, well, Jesus, I lost it. Intercalate examples, and we have lorem ipsum dolor, 3 elements, and then it intercalates intercalate. Let me find it again. Yeah, here. Examples. So we give it a list of elements, we give it what to inject between them, and then it will not only inject it between the elements, but it will also compact it into a single list. So now we have list of strings. It will be list of more strings because this element will come here and here, and then it will flatten it, and it will give us a single string with this thing injected, right? With this space, comma space injected. So this is exactly what we need, right? How like how do I know about it? Same as how do I know about plus? Okay, I've learned that there is this concept of intercalation and you can inject things between other elements in the list. How did I learn about the list? Same as I learned like how to do minus. Like there is a concept of a list. So it's part of my vocabulary, right? So I need to load a module called data list. Oops, wrong syntax. So then I can ask, okay, tell me about intercalate. And it tells me, yeah, there is this thing which you give it a list of elements and it will and an element and it will return you a flat list which kind of injects the thing that we need, right? So if I say f equals intercalate combined with map of show, I solve my problem. And then if I say 1, 2, 3, or 4, it does not work because we didn't say what we want to intercalate the result with, right? So now if I put it like this and recall F1 to 4, we get this solution, right? So now you can think, oh yeah, so if I have this problem, all I have to do is to do intercalate, comma space, and map show. You will miss the point because the point is not the solution. The point is the vocabulary and the thinking which goes to solve it, right? So the vocabulary is this, is show. You didn't know about show. So now you know. Show takes whatever and converts it to string, right? So now you have one more word in your vocabulary. You know what show is. Mapping. Mapping a function over elements of the list. That's another concept. It's like doing addition or doing for loop. It expands your vocabulary. What is this dot? This dot is a concatenation of two functions. I have one function and then it is concatenated with another function which takes output of this with as an input to this one, right? So this function needs two arguments. It needs the what it intercalates with and the list of where to inject. And this function returns a string, and the string no, it returns a list of strings because we have numbers and then we have list of strings. So then we learn about intercalate and then we have a solution, right? So the kind of a key element here is this intercalation and the map. And intercalation is actually a combination of two things. So if I do that f equals concat together with intersperse, and intersperse takes this, and then I have map show. Then if I do my f, you will see that it also works. Whoa, so we learned that concat and intersperse is the same as intercalate, right? Great. So now we have even more concepts. We have a concept of intersperse, which is like injecting something in the list. So it's kind of like, so if I say intersperse 0 into my list, I'm gonna get 1, 0, 2, 0, 4, right? It injects 0 between those two elements and 0 between two elements. So it's like partially doing it, right? But concat flattens the list. So it like I have a list of elements, and then if it would be a list of lists, it would make it just a flat list. That does not make here because we already have a flat list, so I cannot concat a flat list. But if I have a flat list of strings and I inject a string, then I have a flat list of lists because each string is a list of characters. Then I can do concat on it. So if I do concat, I will do concat on this. Then it flattens me the list. So intersperse gives me the, let's do intersperse again. It gives me a list of lists. And then with the concat, I just have a single list because a string is a single list, right? So what is my point? My point is that you should not remember that the solution to this problem is intercalate dot map show, intercalate with the what you want to intercalate, but you should remember about show, remember about map, and remember about intercalate, and then you can construct the solution every time you need it, right? So don't focus on the solution, focus on the vocabulary, on the concepts, and how they are combined such that you can remember the concepts and then combine them when you need them, right? So I don't remember, like right now I remember because I just did it, but I kind of know that I have map in my vocabulary, I have show, I have to do that, and then I have to combine it with something to inject that comma, and then I need to flatten it such that I get a final string. I remember that this is the solution. Like I remember how to do it, but then the vocabulary is kind of combined together, right? So that's the main point. The main point is every time I'm giving you example, you should focus on the vocabulary, go to the interpreter and try to do it yourself. And then if you don't remember a type of something, or if you don't remember the definition, go to Google or go to semicolon I and kind of try to kind of learn. You can use ChatGPT to explain to you. You can ask ChatGPT like what intercalate, how intercalate works, or how map works. Give me examples. And then you will learn the concepts. So it's the same with the labs. The labs, the point of the lab is not in the solution. The point of the lab is in constructing the solution, is in your thinking of how I can decompose what I need to solve and what vocabulary I will use to combine it. If all your vocabulary is variable assignment and for loops, then you are in a Golang space and it's very, let's say, limiting your mental kind of vocabulary of what you can do. Everything boils down to, variable assignment and for loops. If you learn about mapping, if you learn about folds, if you learn about applicatives and monads, suddenly your vocabulary expands and suddenly you can do very nice things and you can kind of do a fizzbuzz in a way that does not feel awkward or does not repeat the code, but has a very nice way of managing the state, and it's kind of has a very linear, very nice construction, right? So we're gonna come back to it. I have to go, but we will come back to those concepts and to those things next week. But I encourage you to watch the videos and sort of familiarize yourself with the fundamentals, with what is the function declaration of like how we declare the types, what is the function definition in Haskell, and what are the simple functions like operating on lists and operating on like show and things like that. So you get it from the early chapters of the book, you get it from the lectures, and you have to do kind of some finger work. You kind of need to play with the interpreter. You have to ask, okay, what is show, right? We already did that. Like it takes anything and produces a string, right? So like show A, what does it do? It just creates a string out of the string, right? Show 4, it converts 4 to string. You can play with it. You can play with defining functions. And then if you define something that does not compile, the interpreter will complain. And then if you define something that works, you can play with it. And you can say, okay, my A is a list. I have a list of some elements, and then I'm calling F on A. Okay, it works. Nice. So you get kind of familiar with the notation that we don't use brackets and things like that, right? Not very complicated. Like start with the very simple things and build up your vocabulary and build up your skills, right? All right, so I finish here. The rest of the talk we kind of do quickly next week. but I will not repeat the exercise with the comma-separated values. Check what Copilot suggests for you. Check what you will get from the ChatGPT. Will you get this kind of a solution which is based on intercalate? So I will commit the code into the lecture lab, but check if you will get this solution, right? Probably not. You're probably gonna get something that is more ugly or not as efficient or not as concise. But you know, if you tell it like, please solve it, like please convert me a list of things into a comma separated value using intercalate, then it will most likely kind of give you this, right? Okay, so that's it for today. Sorry for rushing it a little bit and spending the first part on a little bit of a rant, but the rest of the material is already in the other two lectures which I gave you, and the last year one is covering some of those katas. I will stop.